All right. All right, here's where we were last time. We are going from quadratic. Before I start that, a couple things. In one of my other classes, I mentioned something like, so-and-so, we'll cover that after the break. Somebody raised their hand in class and go, what break? Thanksgiving break. They go, there's classes after Thanksgiving break. Okay. There are classes after Thanksgiving break. Okay. If any of your peeps are under the impression that the semester ends at Thanksgiving, please clue them in, because especially in one of my classes where I've mentioned it a bunch of times, and plus it was the first day of class, I went over it. All right, so I'm pretty sure you guys are plugged in, or at least if you're not, I don't want to know. That if you weren't aware, there's classes after Thanksgiving, and they're all going to be online. My understanding is that students can come back to campus if they want to, but don't quote me on that. But my understanding is yes, some don't go home at all. Okay? But listen to what student development tells you on that. This is what faculty were told. But there are going to be no in-seat classes. Which for me is a little sad because, you know, some students are going to stay here for their athletic team or whatever, or sport, or maybe they're an international student and, you know, they don't have a flight back home until whatever, or maybe it's safer here than where they're from or whatever. Right? The important thing that you know that classes continue. The last 2 weeks of classes will meet at the regularly scheduled time, this time. Wherever you're at, whatever time zone you're in, it's going to be this time. And I know that's going to put a crunch on people in certain cases that are, you know, if you have a 9 o'clock class, you're on the West Coast, that's 7 a.m. I had a guy last semester in Hawaii. He had to wake up at 5 a.m. for a 9 o'clock class. He was in a class with a guy from Italy. Lives in Ravenna, Italy. 12 hours difference, okay? So we're having a final exam, final, November 17th to 19th. We're going to make an appointment with me. We're going to schedule, plan a good hour and a half, 2 hours, like a final exam slot. Do the final exam that week in person, in seat. Afterwards, after the final, after the break, we're covering certain units. And those units, alone, just those units, will be on the test, one test, in the final exam slot. There will not be a cumulative final in December. So the final that you'll take online is going to be over substantially less material. I will say the material itself is a little harder. But it's from my perspective, in teaching college algebra for business, it's the best. Because chapter 5 is, go ahead and look at it. Chapter 5 is mathematics of finance. Yeah. And we're going to be talking about different kinds of compound interest. We're going to be talking about annuities. We're going to be talking about perpetuities. We're going to be talking about things called amortization schedules, which every single one of us at some time in our life has to deal with an amortization schedule. Does anybody know when? Does anybody know what an amortization schedule even does? Anytime you make fixed payments to pay off a debt, such as a car payment or a house payment, which is called a mortgage, right? Anytime you do that, there you have what's called an amortization schedule. You have a fixed, agreed upon string of payments 15 years, 30 years for a mortgage, whatever. So much a month. The amount per month does not change. What changes is how the payments are made up. Every payment you pay, you're paying some interest and some what's called principal. Some interest to the bank, and the principal goes against your debt. So you owe a little bit less. As you go on in paying off a mortgage, for example, your payment amount stays the same, but the amount of each payment that goes toward your debt increases, and the amount of interest in each payment decreases. And so that's what we're going to be doing in chapter 5. Very, very practical, very hands-on, especially if you're going into any kind of finance or accounting. All right. Anyway, moving on. Section 3.3, quadratic functions, as opposed to a quadratic equation. Right? A quadratic function has that form. That looks pretty familiar, right? And we've been solving things that make that equal to 0, right? But now we're doing quadratic functions, and one little parameter we have is that a does not equal 0. Because if a equals 0, you would not have a first term. And you just have a line. Okay? So we know everything there is to know about lines, right? So we're going to do quadratic functions now. So a is not 0. Example, which of the following are quadratic functions? Minus 3x squared plus x minus 3. Is that a quadratic function? Yes. Five x squared? Yeah. Because that's 5x squared plus 0x plus 0. That is in this quadratic form, right? That's cool. That's cool. Then we have x minus 2. Is that? No. And the reason why that is no. No. Why is it no? Because a is 0. There is no x squared term in that. And lastly, x to the minus 2 plus x minus 1. That is also a no. N. I'm trying to be fancy. N. O. Why? This. You have x to the minus 2, where if it's in quadratic form, you only have an x squared term, possibly an x term. You don't have to have an x term. B could be 0. C could be 0. But you've got to have an x squared term. And no other powers of x. So when you have a quadratic function, we have done this already in here. It's going to be a parabola opening either up or down. This should not be entirely new. And we already know a bunch of stuff. For example, one little tidbit is the C term is the y-intercept. Because how do you get the y-intercept of any function in the universe? Plug in 0, yeah. So if you plug in 0, these terms with x in it go away, and you just have the constant. So C is the y-intercept. Another little feature is the bottom point down here. It's called vertex. And it could be, instead of a bottom point, it could be a top point, right? It could be that. That would be the vertex. And by the way, it's got a parabola will open down, a quadratic function will open down if A is negative. It's going to open up if A is positive. And A can only be positive or negative because it can't be zero. All right? So the x coordinate, we get this vertex. We need the x and y coordinate, the vertex down here. The x coordinate is minus b over 2a. Now you see the problem you're going to have if a is 0. You have an a in the denominator. But if a is 0, you have a line anyway. So we're not interested. We know about lines, right? So we're assuming a isn't 0. And then for the y coordinate of the vertex, you plug in minus b over 2a, which is this. You plug that into the function and get the corresponding y coordinate. Or you can do this. Now, minus b squared minus 4. B squared minus 4ac, does that ring a bell? Yeah, that's what's under the square root of a quadratic in the quadratic equation. Divided by 4a, and it's a negative. Okay. The vertical line, this vertical line right here, this green thing on the right, that is called the axis of symmetry. And it is just the line x equals minus b over 2a. Now, let me just show you something. If you know the quadratic formula, a lot of this stuff is in front of you. Because the quadratic formula is what? X equal minus b plus or minus square root b squared minus 4ac 2a. You recognize that. There is your vertex. Here is the top part of that, right? And it's 4a in the bottom, not 2a. That you just have to remember. All right. Oh, my ADHD brain just flies off sometimes. For the final exam, which is the exam before Thanksgiving, you will be allowed to use a 3x5 index card. I think this is on the syllabus, but if it's not, 3x5 index card, front and back, for any formulas, any examples, anything you want, front and back. Small as you want, but it's got to be handwritten. Okay, fair enough, handwritten. All right, handwritten, front and back. You can put examples, you can put formulas, you can put pros from your lover, whatever. You would not be the first. I've seen a lot of 3x5 cards in 40 years I've taught algebra. Right? So be thinking about that now. Be thinking of what you'd want to put in. If you're smart, you're going to take an index card, stick it in your book, and while you're studying, you go, oh no, oh geez, whew, that formula, I'm never going to remember that. Right? And you know what you're going to have? If you start doing your card now, if you start doing this 3x5 card now, you know what you're going to have in a month? You're going to have a personalized study guide. I'll tell you why. What do you put on the card? Stuff you know you're going to know, or stuff you might be a little bit shaky in? That's what you're going to put on the card. Stuff you're not sure you're going to remember. You might remember it, but I'm going to put it down. And so by the end, by the week before Thanksgiving, you got yourself a tailor-made by you study guide. Now, there's probably more you got to study than is on the card. I get it. Okay, but I've had many students come up to me after the final exam. Many students say, Mr. Miller, I worked all night on this thing. I didn't even use it. I go, yes, you did. Oh, yeah, you used it. You just didn't look at it. But making that card ingrained it on your brain so you didn't have to use it. Really, the less you use it during the exam, in one sense, the more you learn. Somehow that got into you, right? Somehow that got inside you. So anyway, moving on. For this function, find the vertex and axis of symmetry. Vertex. Minus b over 2a. Here's a. Here's b. Here's 1. Here's c. Minus 3, right? Minus b is minus 1 over 2a. Minus 1/4. Y-coordinate of the vertex. I take the x-coordinate of the vertex and plug it in. So that's going to be f of minus 1/4. You're going to have a little bit of fractions here. We ain't scared of no fractions. No. Miller, let's not do that again. No. There's some things you can't unsee, right? Yeah. And a 60-year-old math professor trying to dance, that is one thing you can't unsee. All right. So 2 times minus 1/4 squared plus minus 1/4 minus 3. We ain't scared of no fractions. What's that going to be? 2 times 1/4 squared is 1/16. Minus 1/4 minus 3. Two times 1/16, 1/8, minus 1/4, minus 3. Common denominator, 8. 1. 1/4 is 2/8 minus 2. 3 is 24/8 minus 24. 1 minus 26 minus 25 over 8. So the vertex is minus 1/4 minus 25 over 8. All right. It also asks for the axis of symmetry. What is that? X equal minus b over 2a. It's x equal this thing. And so that's minus 1/4, right? So x equal minus 1/4, which is a vertical line, is the axis of symmetry. And like I said, you think a guy named Mark Miller would write really good double M's, but nope. Symmetry. Who knows how many humps on there? The number of humps depends on how long since my last cup of coffee. Graph. Well, we got this. Oh my, we got all kinds of information, right? So now you should be able to graph one of these buzzers with all the trimmings. So for example, we have y-intercept of minus 3. The vertex is minus 1/4 minus 25/8. Now, minus 25/8 is a little bit less than minus 3. So it's going to be a little bit below minus 3. If it were minus 24/8, it would be minus 3. So minus 25/8 is a little bit further down. We have our axis of symmetry. X equal minus 1/4. What are we missing? X-intercepts. So for x-intercepts, you solve the function equal to 0. That's going to be 2x squared plus x minus 3 equal to 0. We've done this one. We've done exactly this problem before. And how did that work? It's going to be a plus 3 minus 1. And so you're going to wind up with x equal minus 3 halves, x equal to 1. So x equal minus 3 halves is around there. Positive 1's around there. And our graph is and that's our quadratic function with all the trimmings. Everything there is to know about a quadratic is on there, right? Axis of symmetry, vertex, intercepts, everything's on there. Be able to do that by hand. Any questions? This is what you missed in Calc 3 right here. Yeah. Oh, shucks. I lost the last 2 slides because the program crashed, so I'm going to have to recreate put the stuff back up there. All right. Graph this one. A little bit different. First thing that strikes me is it's a negative x squared. So it's going to open. And when we say graph, we mean fully graph, right? So let's do intercepts. Y-intercept, plug in 0, it is y equal 2.
That was easy.
X-intercept, it was. X-intercepts. You solve. I'll be a little bit careful in this one. I would not try to factor that the way it is. You're going to get that minus sign in front of the x squared is a little bit tricky. I would multiply through by minus 1. Uh-oh. Guess what? I don't think that's going to factor nice. Does it? No. I don't think you can factor that into parentheses. At least I'm not thinking of how. But that's okay. That's okay. We got the quadratic formula. X equal minus b minus 3 plus or minus square root. B squared, 3 squared minus 4 times a is 1 times c is minus 2 over 2a. That's going to be minus 3 plus or minus square root of 17 divided by 2. I'm going to view that this way. You're going to have x equal minus 3 plus square root of 17 over 2. X equal minus 3 minus square root of 17 over 2. Now, square root of 17 is about what number? Square root of 16 is 4. Square root of 17 is a little bigger than 4. So minus 3 plus something a little bigger than 4 is around 1. So this one's around a half, approximately. Minus 3 minus 4 is around minus 7/2, minus 3.5, right? Those are approximate, but they're close enough to do the graph, right? So we're going to go over here. 2 is my y-intercept. Minus 3.5. So that's going to be minus 3 minus square root of 17 over 2. And then around 1/2, that's minus 3 plus square root of 17 over 2. So I got these points here. Now what do I need? Vertex. Right? I'm going to do a little modification here, only because I can. Oh, no, can't. Aha, liar. Liar, pencil, flower, can't do it. All right, so this way. We need the vertex, right? The x-coordinate of the vertex, we already have it. It's going to be minus 3/2. Right? So minus 3/2. It turns out that's going to be exactly in the middle of those two. Exactly in the middle. And then the line, x equals minus 3/2, is the axis of symmetry. All I need now is the y-coordinate of the vertex. Let's do that other formula. Minus b squared minus 4ac over 4a. What is that? B squared here is going to be minus 3 squared minus 4 times a is 1 times c is 2. All divided by 2a is 2. No, by the way, do I expect this amount to be positive or negative? I expect it to be positive. I'm not sure I'm getting what I want though.
On the bottom, it's supposed to be 5.
Oh, what am I doing? 2, 4. Even that, I don't like that even. Better. Okay, I like that better. Thank you. There you go. 4 times minus 1. Oh, I got one more thing too. 4 times a, this is a minus 1 here. Okay, so careful here. Minus 9 plus, I should have known what that was. That's an 8. It's going to be a 17, of course. Divided by minus 4. That's going to be a positive 17/4, which is a little over 4. So up here, that is minus 3/2, 17/4. And we have everything now. I'm going to move that 2 up a little bit. All right. So my graph is going to be, go through my x-intercept, y-intercept, up to my vertex, down through my other x-intercept. And that's f of x. Now, you notice I hesitated down here. The reason why I hesitated is when I didn't have that negative in there. And it was coming out to 9 minus 8. That would have been 1. That would have put that vertex down here. And that couldn't be right. Because no parabola is going to go like this. Kind of crazy, right? So I knew I had something. These things tend to validate each other. So if you get one that doesn't stop fitting with the rest, go look at your onesie twosies. Go look at your algebra. Questions? Okay. This is an example of a quadratic from real life. A cannonball fired from a cannon will follow the path of a parabola given by that. Wow. That's ugly. But welcome to real life. This is the way real life is. Real life is ugly. It's got a lot of, it's messy. Math gets messy in the real world. Yeah. So that's the graph. Now, does this strike you? X is the distance downrange in feet that the cannonball goes. Okay. All right. Look, 1 plus s squared, that's a constant. V0 is a constant. So this is really like this. So this, all this right here is a big, that's a constant in front of x squared. Notice that it's negative. So that means the parabola opens down, which just makes sense for a cannonball. It's going to go up some distance and then down. Now, S is the slope of the incline of a cannon barrel. Now, I'm not very good at drawing cannons, right? If this were the ground, and I don't know, cannon like that, and it has a big barrel. Right. S I know this is almost excuse me dancing, right? And the ball's coming out, right? So the S has to do with the incline. So if you angle it further up or further down, that's going to affect how far it goes. V0 is the initial velocity in feet per second. That's like the muzzle velocity. It's a constant. X is the distance downrange in feet. Suppose that the cannon is elevated with a slope of 0.5. Now, I don't know what the units are there, but that means something. It's like about 27 degrees, maybe around like that. Okay. The cannonball's initial velocity is 250 feet per second, which is about as fast as your average paintball. You've been hit by a paintball? Yeah. Now, the pros, they get like 350 feet per second, 400, right? But, and the cannonball's initial velocity is 250 feet per second. How far will the cannonball travel? So I'm going to go into my thing up here. So let's see here. F of x is minus 16, 1 plus s squared. S is 0.5 squared, left parenthesis, divided by V0 squared. Oh, guess what? My board just crashed. I know. I'm going to get out of this one. Yeah, that one. Over here. The board can only take so much writing before it, right? I don't know why it picks my computer to do this, but they've looked at it. I've had the IT people look at it, and there is no telling what the problem is. So we can't find out what the problem is.
Probably because you're a math teacher.
Yeah. Well, I write a lot on the boards. Most students tell me I write more on the board than the rest of their classes put together.
Okay.
But I teach math, so that's part of the. I could have it. I could have all the slides and all the work already on the slides, and just point out stuff. I could do that, but that leaves you as pure spectators. And I think it's healthier if you're writing a set of notes. It's processing. Yeah. Hey, look at that. Uh-oh, we lost that. Did we finish this? We did. Okay. All right, so let's try this again. Oh, we lost everything up here. All right. Well, all right, so we're going to have minus 16, 1 plus s squared over V0 squared, x squared plus sx. Let's try that again. We're going to have f of x is minus 16, 1 plus 0.5 squared, divided by 250 squared feet per second, plus 0.5 x. Oh, no. No. This is x squared plus 0.5 x. All right. How far will the cannonball travel? Well, now this is set up ideally for a calculator, right? And that's what I would use, right? Because we need to find x such that it equals 0. No, I'm sorry. How far will the cannonball travel? Let's see. Not liking something here at all. Let's graph this. Let's graph this right here. So we're going to do, we're going to solve this equal to 0. Because that's when it hits the ground, right? And so, so that is going to be, let's go to our calculator. Oh, shoot. And you have a little thing over here, what we're going to do. Now, here, 1 plus s squared. Okay. Oh, I see what's happening. All right. So we're going to do, go to our menu here, clear. You're going to do minus sign 16. Right? Parenthesis. 1 plus 0.5 squared. Right parenthesis. Divided by 250 squared. Right? I could put all that in parentheses and times it by x squared. But I'm not going to, because it's going to do that anyway. X squared. I'm not dividing by 250x squared. I'm dividing by 250 and multiplying everything by x squared. That's how the order of operations there work. Plus 0.5x. Now, once again, we're going to graph that. That looks kind of boring. But you got to interpret that. Hey, Mr. Miller, I got a line, right? Well, did we get a line? It looks like a line, but it may not be a line. All right. Now, for one thing, this thing has been hanging up. I don't know what is happening. My calculator crashed. That happened in calculus too. I don't know what happened. Let's try this again. It probably did not save the. No, it did not. Okay. Minus 16. Left parenthesis 1 plus 0.5 squared. Right parenthesis divided by 250 squared. X squared plus 0.5x. And I traced it. Oh, why is that so flat this time? Because my window. Now, let's just think for a second. Let's go zoom 6. This gives me what I had a second ago. How do I know what values I need? How do I know what values I need for my window? I'd recommend going to a table. So I would hit second table set. I will start at 0. Yeah, let it increase by maybe 25. Right? And then look at my table. And this tells me how far it's going to go, right? I see it's still going up after 250 feet, right? So I'm going to set my table different. I'm going to let it go by 50.
Mr. Miller?
Yeah.
How do you get to the table once you do the table setup?
Do second and graph.
Oh, thank you.
So you see, here, you see it's coming down. Start to come down, right? So I see about what my table settings have to be, or my window settings. My X has got to go from 0 probably to 1,000 or something. My Y's got to go up to at least 150, 170, maybe 200. So I'm going to go here. I'm going to go minus 200, 1,000 for my X's. Go up by 100. X scale. Y minimum minus 50. Y max 250. Y scale 25. See if that does it. Oh, see, I didn't make my X max big enough. X max, make that 2,000. Okay. Now remember, X is my horizontal. That's how many feet it goes. I want to find this 0 right here. Right? So I go second, calc. I want to find a 0. This says in what range? I'll do it from 1,000 to say 1,900 or 2,000. Uh-oh. Enter. And it's 1,562.5 feet, which ironically is the same thing I got before over here. Okay. So I'm actually going to go like this. All right. So our answer is 1,562.5 feet. What is the maximum height? We can do that very quickly. We got like 30 seconds. All I want is that maximum height there. So I'm going to go second calc, max. 4, I don't know, 500. Left bound, right bound, 1,000. As long as I include that peak in the middle, hit enter. And maximum is 195.3125 feet. So it's 195. All right. We'll leave it there. See you next time on Friday. We're in the middle of that example still, but we'll do the rest. Good, Josh. Take care.
Thank you.
Play well.
Thank you.